then you have to run the container images right in the container instances. Before getting it inside, I would like to show you a small demonstration of it. So I have already created the demonstration, but I would like to show you from the scratch. So what I did is I used a .NET, and in that .NET, I created a application of type MVC, Model View Controller. It is a website. And this application has a controller called Home Controller. This Home Controller has methods index and privacy. When you call index, it will going to return its view, means the presentation logic, index form. And if you call privacy, it will going to call privacy. So this basically will have one page having two options. Now, if I want to run it, I can run it locally here, but I want to deploy it as a containerized application. So if I want to deploy it as a containerized application, I have to create a Docker file for the same. The beauty of Visual Studio is that it will allow me to create that Docker file graphically. So I can right click on my project and I choose add Docker support. When I click Docker support, it will tell me that which operating system your application needs. It is in .NET 6, which is compatible with Linux and Windows as well. So I'm choosing Linux. So when I do that, it has created a Docker file. And it is in the root folder of my application with a name Docker file without any extension. And it says that, right, it is explaining me that I need to have the image. I need to work with an image. So which image? So I'm using from mcr.microsoft.com.net/asp.aspnet 6.0 means I want to use this image as a base image. It will bring the .NET runtime. Then I will set working directory as /app and expose it over the AD. Then I also want SDK. I also want to have SDK. So I imported another image which will bring SDK to me, SDK 6.0. And then working directory is source. Now I say that in my project, I have a project file called CS project, right? I want to copy that it into container within a folder called customer management. Then I will restore all the missing packages that are there into it. Then I will copy all the files in my current project into the current working directory. Then I would like to build. I set my working directory as customer management, where I have copied the CS project files and restore the packages. Then I will say that I would like to compile my project and generate a release mode. So I will compile my project, right, and publish it. And after publishing it, it will go to the /app/build folder. Then from build as published, I am actually specifying the run command. So .NET publish. So after building it, I build it, I compile that, now I publish it. So I publish my project into the publish folder. So it is a build project, it is a publish project. So whatever I have built, there is no error, so I'll publish it. And once it is published, then I will specify that what exactly I need to do. So I'm copying all the files from publish folder in the current directory. That is current directory is this. And then I will say that entry point. When my containers start, then customer management.dll will be starting point where I'm defining that how my application will going to run. Right. So how it will going to run. Right. So I define that. So that's what my Docker file is there created. Now I need to convert this Docker file into an image and put that into a container registry. So there are two ways of putting that into a container registry. One, I can create a container registry from here. So you create a resource and search for container registry. When you select a container registry, you'll get the first option, that is Azure Container Registry. You click create, and then you will provide the parameters, which subscription you want to use, in which resource group you want to work with, right? You give a unique name for that registry, right? Let's say I'm creating a new resource group. So Cloud Week demo, right? I click OK. And then I want to create a registry name called ACR CW demo. And then location, in which region I would like to create this container registry, and which pricing tier I would like to use, standard, basic, and premium. So I'm using standard. Then networking, publicly accessible to all the network. Networking capability is available when you choose premium. If I go with the premium, you can control that, you can see, right? And availability zone is also available in the premium plan. But I'm choosing basic at present, and then finish. When I click review and create, right, it will going to take little time to create this container registry. I have already created it for you, right? But I can also create it, right? I can also create it. It is also okay deploying. So I'll go to home, and here you can see that I have already created a container registry. So if you just click on container registries service, so you will see that how many container registries you have. Sorry, just let me search for that. Container registries, right? So I have two registries which are already there. Third one, I am creating it, right? So once it is created, it will also be listed here. So go to the resource. So my container registry is created. Let me go back and let me refresh this. So my third container registry is also there, which I have just recently created it. Now, if I just take you to one of the container registry, so you will see that this registry has its own login server, right? Where you work with. And if you go to the access keys, you have to enable the admin user. Because once you enable the admin user, then only people can use these credentials to communicate with this registry, right? Which is available on that server with this username and password, right? If you don't enable it, so people cannot communicate with that. So I did this. Now, this repository, this container registry has a repositories collection where I will store my images. But I don't have an option here to create repositories. Repositories are automatically created when I publish my image to it. Now, let's see how to do that. So I have created this customer management application, and I generated this Docker file. Now it's time for me to publish it to the cloud. So I right click on it, and there is a publish option. I am creating a new profile, publish profile. I say that I would like to publish it to the Azure. Then where in Azure? In the Azure Container Registry. Then it will connect to my subscription, and it will give me any container registry that I have. So it takes little time to bring that. So you can see my ACR CW demo is there where I can publish it, which I've just created it, or I can use any other container registry. So I'm choosing this container registry, which I have just created it. Or even you can create your container registry from here on the fly. Now I selected this and I click next. Now it says that when you want to deploy your application as container image, so how you want to generate a container image? Do you have a Docker desktop, or you want to use .NET SDK? So it will build the container image using .NET SDK. So no Docker file is required. No, I say I need a Docker file. So I have one. So I selected it and I click finish. So when you click finish, then your Docker desktop must be running on your system, which I have installed it before. And then I will click on publish. So I would like to publish it. So it is checking the containers, publishing it to the container registry. Until the moment it is running, I just want to show you that I have a Docker desktop running on my system. It is an application that I have installed, Docker desktop. So it is publishing my images. So it will take a little time. So now it has compiled, now publish succeeded. It is pushing the changes. So login succeeded, connect to the container registry, and then it is trying to connect to the registry and converting your Docker file into an image and pushing it there, pushed, right? So once it is done, then I would like to go to my container registry that we just created. and I try to refresh it. So it will take a little time to bring that back. So I'm just waiting for this to get refreshed. Okay, so you can see that in the repository section, I have customer management repository created. And when I click on it, it will have the latest tag. Latest tag means every image has a tag, means version number. So it is the latest version associated with that. And when you click on that, it says that you can run this command to pull this image from the container registry into your Docker engine, and then you can create an image from that, or you can create a container from that. Now my image is already there. Now no matter where I am, I can connect to this repository, get this repository, and then create a container instance on the same on that. So let's try to see the next example, which will come in the next slide, but I would like to show you that how to create a container instance. So let's say I want to create a website, because it is a website, right? So it is a website which I have deployed in as a container image. So I need an environment for that, like web app. So I will create a resource and I will choose web app. So when I say that I would like to create a web app, I will choose the resource group where I would like to create this, give it a name, customer management app, and it will be fully qualified name. It is already used. So customer management demo, it has to be globally unique, right? Now, I don't want to deploy it as a virtual machine. I want to deploy it as a container, Docker container. So I selected it. Which operating system your application needs? I selected Linux. So I will choose Linux here. And which region? What will be the compute capacity? So I can choose a compute capacity like standard, right? And then I have to define the Docker details, which image I would like to use. So I say that to create this web app, which run in a container, I want to work with the image that is coming from the container registry. So I have 3 registries, so it will show me all the 3 registries. So I can select the registry and it will show me the repositories that I have. I have only one repository there, which I have just deployed with the latest tag. And then networking. It is publicly accessible. I don't want any monitoring on that, and review and create. So it will take a minute or so and your web app is created. And if I give this URL to you guys, then when you open that URL, you will be able to see your web application, and it is running in a container. So it is a containerized app. So no matter who you are, if you have a permission to connect to the container registry, you can use the image inside, which is available as a repository, and you can create multiple instances of the container with the same image. So that is the idea behind it. So it will take a minute or so till the moment it is working. I would like to talk about the next few things that is coming into your way. That is called run container images in Azure Container Instances. One of the example I've just shown it to you how to do that, right? So after completing this topic, you'll come to know that what are the container instances, how to work with them, right? How to deploy a container instance by using a portal, which I've just shown it to you, work with a CLI, how to start and stop the container using policies, environment variables, sharing a mountable drive. So all these things which we will be talking about is on the way. Let me see whether my container is ready. Yes. So my container is ready. So I'm going into my web app. So I went into my web app and you will see that it will give me the URL of it. So I'll copy this URL and I paste it here. So when I paste it here, so it has opened the home page. You can see it has a home and privacy options, which I told you, which is there in my application. So if I went into my application controller, home controller has index and privacy. And in the index method, it is just showing you the link, learn about this. Title is homepage. Let's see that. That is what, learn about this, right? And if you go to the privacy, so it is showing you this privacy policy. Use this page to detail your site privacy policy. So if I go back into my privacy mode, so it is showing you that. So it proves that I have deployed my application as a container containerized application in the cloud. Now, the benefit is that you can even stop that and restart it. So when you restart this app, it will going to restart it in few seconds. If it is a virtual machine, it will take 4 to 5 minutes to restart it. You can say successfully restarted it. How quick it is? A few seconds. It take a few seconds to restart that because you're not restarting the complete operating system. Now, the benefits that you will get from this container instances, right? So fast startup time because you are not starting the operating system, right? So it is talking about the basic benefits that you will get, right? Public IP connectivity and DNS, because when I was creating it, it is publicly accessible and it does the mapping that if any request comes at the port 80, where it will go inside the container. So that's how it works. And it generates the unique address to that IP. Hypervisor level security. Container applications are as isolated in a container as they would in a VM. So each container will run in isolation with each other, right? So there is no relationship between one container to another and they can't directly talk to each other as such. Custom size. When we create a container instance, we specified what resources I need. Persistent storage, because if container gets deleted, all the data will be deleted, whatever I've stored in the container. But if I want to maintain the data, right, so that if I create another container instance, so it can also use that information, so I can mount a Azure file share with it. Then we have Linux and Windows container. We can create containers which are based on the Linux operating system or Windows. Choice is yours, right? Then we have co-scheduled groups. Now, there is another concept, like by default, I create one container in the container group, but you can have multiple container groups, multiple containers in a container group. One which is publicly accessible and other which are used in background, right? Let's say one container which is using some database, which I don't want to expose it to the outside world, right? So I can do that. We'll see that how it look like. Then network deployment. If I'm using a premium, if I want, I can deploy my container instance into a Azure virtual network. And then I can configure the inbound and outbound rules, which requests can enter into that network and which requests can go outside that network. So I can manage that with ease, right? So what next? So they're talking about the containers group, right? What it is and how it works with that. Run container images in the container instances. So as you can see onto the screen, right, that whenever we are creating the container, actually it creates a container group. Container group is the top level resource in the Azure container instance. Whenever you create a container instance, the container group is the topmost object in the hierarchy, which is a collection of one or more containers, right, that get scheduled on the same host machine. So all the containers which are in the container group will run on the same machine, right, as containers. And each container, whatever containers you have in a containers group, will share the same lifecycle, resources, local network, storage volumes, right, which is associated to your container instance. Usually, I say I have one container in a container group. So one container instance has container group having one instance, which has my website, and that website might want to access the data which is running in on-premises or maybe in the cloud. But when I'm talking about that, I also want to bring that database in the as a container. I want to bring APIs which my application can call, right? So I can put that into the container group and I can expose my web application over port 80 so that people can communicate with that. And my application can talk to other containers on different ports, but they are in the same container group. Now, to create this, right? You need to work with the YAML file or resource manager template. You cannot do it graphically. So multiple containers in a container group, right? If you want that capability, so you cannot do it with the portal. You need to work with the ARM templates or a YAML file. So a resource manager template is a recommended option when you want to deploy additional resources or additional service resources, right, with a container instance. And I told you, you can work with the resource allocation. Azure Container Instance allocate resources like CPU, memory, optional GPU-based resources when you are creating a container instance. Another example I would like to show you here, just sorry. So we have a service called Container Instance. Container, one or two containers, so you can do it manually. So you can click on Create Container Instance, right? So it will create one container group having one container inside. So in which resource group you want to create? What should be the container name? So my customer management app, I'll copy that because I will use it as a DNS name. In which region? Availability zone. Now, which plan you want to use? So standard, right? So it will decide that how it will going to work, how what resources will be allocated, right? Standard SKU, right? So what type of security it will provide? Now, what is the image? So my image is coming from container registry. Which container registry? Which repository? So it will show me the my repository, means my image. And then this is the size, compute capacity, which we were talking about. So I can change the size. I can decide number of CPU cores, how much memory I would like to give. So memory, the memory that you would like to give can be specified here between 1 to 32 gigabytes. The CPU cores between 1 to 8, right? It is in preview GPU based types that you want to attach. And then you can put it in a network. People can access it from public. It can be a private to privately accessible within a network or none. You have to create private endpoint to access it. And then DNS name by which it will be accessible. You are exposing the port 80. And then you click review and create. If you want to run some scripts, right? So you can do that as well. But the most important part is the restart policy. So which I will be talking about. There are three options: on failure, always, and never. I'm going to talk about. And then how to encrypt the data. So which key? Microsoft managed keys or customer managed keys. So I click review and create, and it will create an instance. But I'm not going to create it because I have to explain this as well. So once I do that, then I will come back to it. So I discussed with you, when you are creating a container instance, you can specify CPU, memory, and optionally GPU, which is in preview, to the containers group. So these resources will be shared by all the containers that are running in that container group. And container group shares an IP address and port name space on the IP addresses. Storage. If you want that multiple containers can share the data between each other, so you can mount a file share with it. You go to the storage account, create a file share, and then mount that file share as a volume so that all the containers can read the values from it or write the values into it. And multi-containers groups are useful in case where you want to divide a single functional task into small number of container images. Like I have a one big application, but I want to modularize it, right? So each component of an application is running in different container. And my main application is just calling those things. Like I'm working with the tour and travel site. So hotel management, flight management, visa management, either I can put it in one application, but the size of application will become heavy, right? So what I can do is I can create those things as a separate APIs, which are running as a separate container in a same container group. And my main application, which is running in another container in the same container group, can talk to them whenever client request comes to them. Now, as I was talking about that, when you are creating a container, right? So you have an option to deploy the container instance with some policies, right? Like how the container will going to restart. So we can configure the restart policy. The easy and speed of deployment container is in container instance, provide a compelling platform for executing run once task like build, test, image rendering in a container instance. But sometime you need to control that how this container instance will going to restart. So we have three policies and we can choose one of them. Always. When you choose always, so containers in a containers group are always restarted. This is the default setting if you don't choose any, right? But if you say never, so containers in a containers group are never restarted. It will run only once. If it get crashed, if it terminates, so it will never going to start it. You have to manually start that again. On failure, when any script fails or any component fails, so it will restart the containers running in the containers group. Right. So these are the restart policies that you can go with. And here I have the restart policies. So you can choose that. Right. But here, one thing which I have figured it out, right. When I go to the next one, so you can see on failure is a default one. But as per the book, right, when you go to the book, they say that always is the default setting when no other restart policy is defined. But as we can see, when we are just going here, on failure is the default setting that is used. Please keep an eye on that, right? Things might change. So you have to see the practical part as well. Now you specify the restart policy and click create. Now we can also create this restart policy with the CLI. So you can see in the next slide, we are doing it. AZ container create. I'm creating a new container in this resource group with the name my container. This is the image. I can provide the path of that image and restart policies on failure. So I can specify that. What I did it graphically, you can do it with the CLI as well, right? So Azure Container Instance, start the container and then stop it when its application or script exit. When container instance stops, a container whose restart policy is never or on failure, the container status is set to be terminated. Means it will not going to restart automatically because it will going to I said restart never. So it will never restart. The task is over. Container will not going to be used again. But on failure, so it is when container runs completely without any error, so it will terminate. Right? It will only going to restart when there is a failure, but there is no failure. So container status is set to terminated in that case. So we have to be very sure about it, that what policy we are using it. Always, that's why we say it's good. Now we can set some environment variables as well, some key value pairs. Let's say in my container, I want to use some connection string. So I can keep that connection string within the environment variables of my container. So when I'm creating a container, I can set a parameter called environment variables and the key and the value. Numword 5, main length is 8, because I would like to use this key value pair in my programming. But it is stored as a properties. So when I go to the containers property, I can see these values, which is a risky thing if I have connection string. So I can't store it like that, which is in a plain text format. So we have another option to store this information in a secured way. So when I'm storing the value, right, environment variables, I will specify as a secure value. So you can see first is non-secret, not secret, and its value. Second one is a secret. So name is secret. So we are not using value keyword. We are using secure value. So it means that this information will be stored in an encrypted format. If you go to the properties of a container, you can see not secret and secret. But when you click on it, you can only see the value of non-secret. Value of secret is not visible. It is only available with the code. So that is the beauty of the environment variables. Now, the last but not the least about containers is we can mount file shares. I have 2 or 3 containers running in a container group, and I want them that they can share some data between each other. So in that case, I can share the mountable drive. So I can go to the storage account and then I can deploy a container and mount a volume with that. Right. So how to mount a volume? Right. So for that, you need to run a command. Right. So I just want to tell you what command you need to write for the same. We don't have a slide for that. So you will just run a command. Az container means I want to work with container. Right. What do you want? I want to create a container. Then you will pass some parameters like I'm not typing complete, please. I'm just adding a shortcut. RG, it is a resource group. So you will provide the resource group name. Then you will provide the name of the container that you would like to give. Then you will provide the image name, image, right, that you would like to create a container based on. Then you will define the DNS name, right, DNS name label by which it is accessible to the outside world. Then on which port it is available, right, port 80. Then the main thing is that now you need to work with the file share. So you will use Azure file volume, right, name, volume account name, account name. So you will give a name to it, right, my val, a unique name. Then you have to define that where it is coming from, right, account name. So account name is the storage account name. This is the storage account name, storage account name, right, where you have created your file share. Then you have to define the uh, secret key by which you can prove your authenticity. So we will use Azure file dash volume dash account key, account key. This is the key K1. Let's say it is a K1 or a unique value actually. So this key is basically allowing you to prove your authenticity. That request is coming from trusted source. Then you have to define which in that storage account, what is the name of that mountable drive? What is which file share you want to use? So Azure file volume share name, share name. So you have already created a file share called myfs. Now in the container, right, what path it will going to be used to mount it. So last is Azure file volume, right, volume dash mount path, mount path. Now here you will define the mount path, like in my container ACI/logs. So I want to mount this drive with that path. If I try to type this path, it will open the file share for me, right? So I will provide that details. And once I did that, so this file share will be mounted and I can work with that. So this is the way that you will work with. Now, by default, Azure containers instances are stateless. Stateless means when the containers get deleted, everything is lost. If you want to maintain the information, even after the containers are deleted, crashed, and you recreate it. So in that case, you have to persist this information outside the container into external source, and file share is the right option for that. And for that, when I create an instance, I will attach the file share and I can store the data inside. Even when the container is crashed, file share is there. So when I create a new container, I can mount the same file share and I'll get the data and continue with it. Deploy container and mount volume. I have just shown it to you that how to do it with a CLI, as well as you can do the same thing by creating a YAML file where you are creating a container and then you can specify this code, like I want to mount a volume, right, within that YAML file. We can mount multiple volumes as well. We have to define it in a YAML file. So multiple volumes can be attached, one for images, one for maybe documents, one for anything, different things.